Everybody, today we're going to go over the CS10 with stat midterm from fall 2018. Um, so yeah, let's recall what the approach of coding a fractal is. And we have four cases, and we ultimately want to kind of figure out what n equals 5 looks like. And so let's just look at n equals 1 and n equals 2. Recall that n equals 1 is the base case, right? And so in this case, the base case is we're assuming that we're starting at pointing in the direction of 90 degrees. We're going to move size steps, and we're gonna just end up facing the same direction. We're not gonna do anything else, right? N equals 2, right? So we we're gonna kind of start pointing in the direction of 90 degrees, right? So we're gonna like kind of point this way, right? And notice that this is a 60-degree angle, right? Uh, this is a 120-degree angle, but I guess um, when we kind of get to this point, we're going to be facing this way, right? And so we want to kind of ultimately turn left. I believe it's left. It's either left or right. But we actually, when we get here, when we're pointing at 60 degrees, we want to turn. Yeah, I think it is turn left 60 degrees actually, and then our sprite is going to be facing this way. And let's ignore that. Uh, I don't know. Okay, so yeah, once we get here, uh, we're going to uh, this is a 120-degree angle, right? And I believe we're going to be turning right 120 degrees. And the bolded lines is the recursive calls, right? Um, once we made, so we're going to make that recursive call, and we're going to end up right here. So there's two recursive calls, and I guess before we're going to kind of end up facing this direction, but we want to make sure that. Uh, I believe we can double check this. I think this is turning to the right 60 degrees. And then making the next recursive call. So I guess just to break down what we're doing, right? Uh, we're turning 60 degrees. At n equals 2, we're turning 60 degrees. We're moving size divided by 3 steps, I guess, because right here it says 60 degrees. And the 4 n equals 2 lines are 1 over 3 size of compared to the length of the n equals 1 line. So each of the four lines here are 1/3 of the size of the n equals 1 line, right? So move size divided by 3 steps. Turn again, I think it's 60 degrees. Uh, Size divided by 3 steps. Turn again. Recursive call. Turn again. Recursive call. So there's essentially four parts, right? And then we want to make sure that we're ultimately pointing in the direction 90 degrees, right? We're not going to use that block though. Make sure if you don't use a pointing direction block, and when you're making fractals, make sure you're always using the turn block. Pointing direction will not work, right? And yeah, so we can get into that essentially right now. Oh, need to clear everything. So let's start with the base case, right? So the base case is if our level is equal to 1, we're going to move size steps, right? So kind of just slide coding and making sure that everything's working. Uh, so we don't have to debug so much. We're just going to like do all the parts, like do all the small parts as we're coding it live, right? So it looks like our base case is working. Um, so we're going to move on to the recursive case by looking at n equals 2. We're going to ignore n equals 3 and n equals 4. We're going to get to n equals 3 and 4 by the recursive leap of faith, assuming that our n equals 2 and n equals 1 works. We can just assume n equals 3 and n equals 4 will work, right? So we're just gonna rely on that assumption, rely on the leap of faith. But in order to do that, we need to make sure our n equals 1 and equals 2 logic is correct, right? So we need to start by turning 60 degrees to the right, because that's like, okay, we assume that our sprite is pointing in the direction 90 degrees, which is this way, right? But um, it looks like in the picture, in order for us to draw that line, we need to turn 60 degrees to the right. Okay, cool. So now we can, once we pointed in that direction, we can move size divided by 3 steps. Okay, so move size divided by 3 steps, and it looks like we want to turn left 60 degrees. And let's see what we have so far. Uh, okay, I guess we need to make this bigger because it's hard to see. Okay, so I think that checks out so far. And now we want to turn, I think it's actually to the right, 60 degrees. Uh, yeah, or this way, sorry, to the, I think this is to the left. I just kind of use like the motions, uh, based on what the picture looks like. But yeah, so now we're in the right direction, right? And so now we want to move right here, kind of recreate this move size divided by 3 steps. Actually, we can kind of just use the duplicate to save a bit of time. Uh, okay, so okay, that's what we have now, and the non-dotted, or sorry, the non-bolded is the work we're doing per recursive call that's not like part of the recursion, right? And so now that we've done that, we need to set ourselves up for our recursive call, which is the bolded part, right? And so we want to turn left 100, no, actually 60 degrees, yeah, because we're pointing in 90 directions right now. Like we're pointing this way, and now there's a 60-degree angle right here. In order for us to point this way, we need to turn 60 degrees. Uh, cool. Let's actually check if that's correct. Yeah. So now we're ready for a recursive call, right? And we're going to use this fractal. We're going to at each step we're moving size divided by 3 steps, so we're actually going to just input size divided by 3, and we're going to make the level we want to make sure our level decreases by 1 at each step, at each recursive call, right? And now let's see what happens right now. Okay, so it looks like it works, but now notice that we're not pointing in 90-degree direction. For we need to make sure that we point in the 90-degree direction before our next recursive call, right? Um, and so in order for us to do that, we need to turn, I believe, I think it's turn, I think it's 30 degrees. It looks like it's 30 degrees. Um, in order for us to get to that 90-degree part. Okay, it's actually 60 degrees. Um, yeah, yeah, uh, because right here, uh, there's a 60-degree angle in order for us to get there. Um, yeah, this is 120 degrees, but we're saying turn right 60 degrees will get us kind of like right here. Cool. Let's go to annotation. Okay, so now we're ready for the next recursive call, which we can kind of just clone this or duplicate it. And notice that we're pointing in a 90-degree direction, and that's where Alonso, the little sprite, ends up in. So I believe that might be it. So I guess to reiterate what we've done, uh, we set ourselves up for turning the direction, moving size divided by 3 steps, turning again, moving size divided by 3 steps, turning again, making the first recursive call, turning again, making the last recursive call. And that's n equals 2, right? And let's kind of test that out and see where we got with that, right? And that's what that looks like. And that actually looks correct. And now I guess kind of using that recursive leap of faith, we kind of assume the level, assuming that like what we have is correct, level equals 3 and level equals 4 should work. Uh, yeah, we didn't have to think about the level equals 3 and level equals 4. We just looked at n equals 2 and n equals 1 in order for us to kind of have this fractal block work for all n greater than or equal to 1, right? And so this looks like what's the picture has. We don't have to worry about like the dotted, or sorry, the bolded and non-bolded coloring. That's just for us to see what are the recursive cases, essentially. And so I guess during the midterm, they'll probably ask you to submit a level equals 5, just so like we can see like you didn't hard code anything. And so this is kind of what, maybe we can make it bigger, like 300. What does level equal 5? Okay, it gets off the screen, so maybe uh yeah, so that's level equals 5. So yeah, I guess kind of to recap, we have a base case, which is the if statement. Uh, in this case, level equals 1. And then we have the recursive case where the non-bolded lines are the work, this is the work that we're doing for like level of our recursion. And the bolded lines are the recursive calls. And we want to make sure that we're pointing in the right direction before we draw anything. Um, cool. So yeah, thank you guys for watching. If you have questions, feel free to post on Ed. Uh, yeah, thank you.